Here we are on page 3, and I'm using a new pencil. So, well, it's not really a new pencil. It's actually a really old pencil, but I usually never use it. So let me try and see if I can make this work well. Okay, number 6, expand and simplify this expression. And this is a binomial, two things added together, but none of these are variables. Kind of weird. Let's try it out with the template. 2 minus square root of 2 to the 5th. Okay, so to the 5th. So that would be Pascal's triangle coefficients 1, 5, 10, 10, 5, 1. Right? So I'll write those in the triangle. And the A is 2, and the B is equal to square root of 2, or negative square root of 2, right? And remember, if I do B squared, that would be negative square root of 2 times negative square root of 2, which would be positive 2. And if I did B cubed, it would be negative square root of 2 times itself 3 times, so it would be negative, and then 2 square root of 2, right? And so on, okay? That's just a little review so that we can simplify quicker. So the A values are all going to be 2's. And the B values are going to be negative square root of 2. Okay, and then I'm going to put the powers. So the powers are going to start with 5 and work my way down. And then the square shape is going to start with 0 and work my way up. And then I'm going to use the blue ink to cross out anything that is equal to 1. Help me simplify. Okay, now I'm going to, now I'm going to get rid of, or I'm going to simplify what's left. Okay, and I'm not going to put the pluses in yet, because what I'm going to do is I'm going to take my negative signs here, and if it's a negative sign to an odd power, then I'll put it out front as a subtraction. And if it's a negative to a even power, then I'm going to put a positive out here, and I'm going to take away the negative, because the even powers are going to result in positives. So this is negative, so I'm going to put it out front. This is negative to the 4th, so I'm going to put a positive out front. And this is negative to the 5th, so I'm going to put a negative out front. And you can see that, as usual, it alternates positive, negative, negative, positive, negative. Okay, and now let's do our simplification. 2 to the 5th is 32. 2 to the 4th is 16. 5 times 16 happens to be 80. Square root of 2 to the 1st is square root of 2. 2 cubed is 8. 8 times 10 is 80. Times square root of 2 squared is 2. So that would be 160. 2 squared is 4. 4 times 10 is 40. Square root of 2 cubed is 2 square root of 2. So that would be 40 times 2 square root of 2, which is 80 square root of 2. And then 2 times 5 is 10. Square root of 2 to the 4th is equal to 4. 4 times 5 times 2 is 40. And the last one is square root of 2 to the 5th, which is equal to 4 square root of 2. Okay, now I can combine like terms. So I could combine all the integers, and I could combine all the square root of 2 terms together. So the integers together, 160 plus 40 is 200, plus 232 is 232. And then to combine all the square root of 2's, I just add the coefficients. Negative 80 is negative 160, plus negative 4 is negative 164, square root of 2. Okay, and that is my answer. I can't simplify it any more than that. All right, let's move on to the next one. Okay, the next one looks scary. It has a binomial multiplied times a fourth order polynomial. The fourth order polynomial by itself, though, doesn't look too bad, does it? X plus 1 to the fourth, that's pretty basic, right? We could even do that without the template. What do you think? Remember, fourth power means Pascal's triangle coefficient, row 1, 4, 6, 4, 1. Oops, I'm not too good with this yet. Okay. All right, and then I put my a values, which is x, 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 x. And remember, the x's start with the power of 4, and they work their way down. And then finally the ones. Oh, the b value is 1. So if I put 1 here, it would be 1 to the 0, 1 to the 1, 1 to the 2, 1 to the 3, 1 to the 4. What do those all equal? 1. So I don't even need to write them down, right? Okay, 1 x to the 0 is just 1. So I could maybe get rid of that. 1. Okay. 1x to the fourth is just x to the fourth, right? So now what am I going to do? Now I need to multiply this big polynomial with this binomial. Normally what you do is you would do like a megafoil. Like, oh, I'm going to multiply these two together. Then I'm going to multiply these two together. Then I'm going to multiply these two together. Then I'm going to multiply these two together. And then you're going to have a big mess, right? So my advice to you is be organized as usual. How are you going to be organized? You are going to use lattice multiplication. So you make this grid. The grid is 5 wide because there's 5 terms here, and it's 2 tall because it's got 2 terms here. So what are you going to do? I'm going to write the big polynomial across the top. I don't need to write the plus signs because that's kind of understood. You could put negative signs, or you should put negative signs if you have negative signs, but in this case, we don't have any negative signs. This works really well when you have degrees of polynomial that steadily decrease by 1 in both directions. Then it's perfect. There's certain scenarios where it's a little bit more complicated, kind of a mess. Okay, so we're going to multiply this column with this row. So 2x times x to the fourth is going to give us 2x to the fifth. 4x cubed times 2x is going to give us 8x to the fourth. 6x squared times 2x is going to give us 12x cubed. 4x times 2x is going to give us 8x. And 1 times 2x is just going to give us 2x. Easy so far. X to the fourth times 3 is 3x to the fourth. 4x cubed times 3 is 12x cubed. 6x squared times 3 is 18x squared. 4x times 3 is 12x. And 1 times 3 is 3. You can see that that part of it, the shower part of it, is actually very easy to do with lattice multiplication. Now, how do we combine like terms? Well, these are the x terms. These are the x squared terms. Oh, and I can already see that I'm in a mistake, right? Because this is actually 8x squared, and I forgot to write the squared. And I can see there's a mistake because, the geometric pattern here says that I should have, like terms in diagonals. All right, so now what I'm going to do is I'm going to add up everything in each diagonal. There's only a 3 here, so I put the 3. 2x plus 12x is 14x. 8x squared plus 18x squared is 26x squared. 12x cubed plus 12x cubed is 24x cubed. And 8x to the fourth plus 3x to the fourth is 11x to the fourth. Oh, the pencil's getting a little weird. 2x to the fifth, no other like terms, so we just put 2x to the fifth. Okay, so that wasn't too bad, was it? We can use these grids to organize ourselves instead of making a big foil mess. Okay, sometimes there's cases where it doesn't work. It works really well when the powers go up or down by 1, like we are here, and they don't skip numbers. Okay, but we'll do examples later where the numbers skip, and we'll see how to handle that. Okay, So let's move on to number 9. Find the coefficient of a cubed b squared in the expansion of 3a plus b to the 5th. Now, there's a clever way to do this, which we're going to learn later, but for now we're just going to use brute force and expand the whole darn thing and see which one is a cubed b squared, okay? So the a term is going to be 3a and the b term is going to be b. Oh, so the a term is actually going to be 3a. Is that confusing that we have a twice? So the a is going to be 3a, and the b is going to just be b. Okay, and of course the Pascal's triangle coefficients are going to be 1, 5, 10. 1, 5, 10, 10, 5, 1. Okay, and then the a terms are 3a, so we're going to put 3a, 3a, 3a. We just don't need to put it on the last one because remember the last one is going to have a exponent of 0, so it would just become 1 anyway. And then we're going to have b's, and the b's don't really need parentheses because there's just one letter, but you know what I mean. Okay, and the coefficients for 3a are going to start with the 5 and work their way down. And the last one's 0, that's why we didn't write it. And then the b's are going to start with 0 and work their way up. Okay, and then we could put pluses in between. And then b to the 0 is just 1, right? So we'll just cross that out. Now remember, if I have 3a in parentheses to the 5th, that's 3 to the 5th, a to the 5th, right? But basically, all we want to know is the coefficient for a cubed b squared. Which one is a cubed b squared? Well, it's not this one, because this one's a to the 5th, right? This one's a to the 4th. It's not that one. Maybe it's this one. A cubed b squared. Yeah, so it's this one. So we're not going to simplify any of the others. We're only going to simplify this one, because this is the only one they want. They want a cubed b squared. This is a method which they use to make binomial expansion problems take less time. Instead of asking you to expand the whole thing, they're going to ask you to expand or to show you one term only, and they specify it using some specification like this. And then you really have to know what you're doing so that you don't waste a lot of time expanding everything. So we know it's this one, and the reason why we know it's this one is because this one has a b squared, and if I expanded this, I can see that it would be a cubed. The other ones, obviously, are the wrong powers. So I'm just going to simplify this one. So it's going to be 10. And then the 3 cubed a cubed is going to be, 3 cubed, by the way, is 27. A cubed b squared. I'm almost done. I do need to combine the 10 and the 27, simplify that, and multiply them together. So my coefficient is going to be 270 a cubed b squared. And then I'm done. Now, some people might say, oh, a cubed b squared, the coefficient is 10 because the Pascal's triangle coefficient is 10. But actually, remember, coefficient is any numerical element, right? So the 3 and the 3 cubed is also going to have to be combined with the original Pascal's triangle coefficient to get the total coefficient 270. So the answer is 270, not 10. Okay? All right, let's move down a little bit to the next section. We're going to learn how to use the calculator to do factorials. Factorial is super important to figure out Pascal's triangle coefficients without building a whole darn tree. Sometimes you're going to have to figure out row 15 of the Pascal's triangle, and you don't want to have to build the thing out to row 15 because you only have 30 seconds to do it, and you have the calculator to help you. So why would you spend all that time building your Pascal's triangle coefficient? Okay, first of all, factorial looks like you're yelling out the number. It looks like and because there's an exclamation point, but really what this means is n times one number less times one number less. So it's a little bit easier if we think of it as, numbers. So what about like the 5 factorial, for example? What if we saw 5? If we saw 5 factorial, that is actually equal to 5 times 4 times 3 times 2 times 1, which is actually equal to 2 times 3 is 6, 6 times 4 is 24, 24 times 5 is 24 times 5 is 95? No. 24 times 5 is 124. No, 120. Sorry. 120. Okay? But we could do that on the calculator. Why don't we do it on the calculator? Let's turn on the calculator. And then we're going to put 5. And then we're going to go into math. And then we're going to go into PRB, or probability. And then we're going to go to number 4, which is the exclamation point. And then we find out that the answer is 120 using the calculator. Okay? This is kind of a general form for the factorial. And basically what they're saying is, if you have n factorial, that means you're going to take the number n and you're going to subtract 1 from it. You're going to multiply it times that. You're going to subtract 2 from it. You're going to multiply it times that. And so on. ... Until you finally get to the last few numbers, which are 3 times 2 times 1. Once you get to 1, you stop. Do you see what I did here? 5 factorial is 5 times 4 times 3 times 2 times 1. It's a lot easier to understand when there's a number here. When there's a variable like n, then people have trouble understanding. But basically, you can see that this is like, if this was 5, this is 4, this is 3, this is 2, blah, 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 until you get to 1. Okay, 0 factorial. Just so that everything works out, 0 factorial happens to be 1 and not 0. Okay, so 0 factorial is 1. Just remember that. 0 factorial is 1. That's the only weird one. Okay, and of course you can't do factorials for decimals, and you can't do factorials for negative numbers. Express the binomial coefficient as factorials of n and r. It turns out that you don't need to build up Pascal's triangle to figure out the coefficient for a Pascal's triangle coefficient. You could just use a function called factorial, or I'm sorry, a function called n chooses r combinations. Where is that? On the calculator, it's located also under the probability menu here, NCR. Okay? Now, NCR is sometimes expressed with these parentheses, with the n on top and the r on the bottom, but on the calculator, it looks like this, NCR. Okay? Same thing. What is this used for? It's often used in probability. What does it do? If you give a certain number in the n and the r, it'll give you all the ways you can choose 2 items out of 5 or 6 items out of 10, depending on what n and r are. Now, do you need to understand what that is? Well, you kind of already do, because remember we went through all that pain and suffering in the investigation, and we figured out how many ways are there to arrange 2 U's among 4 players, or 1 U among 3 players. Remember doing Doizon? So we already kind of have used these before. Okay, so basically the n is the number of players and r is the number of U's distributed among those players. Some of the players are playing Dois and some of the players are playing How many Ums were played, for example? Okay, all right, anyway. So what is the formula for n chooses r? The way you read this is n chooses r. The way you read this is n chooses r. Okay? So the way this formula, if you read the book, it's defined as the numerator is n factorial. Oh, there's n factorial again. And the denominator is n minus r factorial and r factorial. Okay, that looks like a big mess. This is in the formula booklet, so you don't need to memorize it, okay? Remember, this is also written not only as parentheses n chooses r, it's also written like this, it's also written like this, on the calculator it's written like this, okay? You still don't know what it is and how to use it, okay? We're going to show you on the next page, okay? But just so that you can see how familiar this is, I'm going to show you how you can use n chooses r to generate terms for row 6 of Pascal's triangle, okay? So first of all, I'm just going to stick this here, and I'm going to put 6 chooses 0, and that's going to give you the first term of row 6. Pretty boring, because we already know that the first Pascal triangle number is always 1. Now I'm going to say, what is the second coefficient of row 6? Yeah, it's 6. We already knew that too, right? The next one, maybe we don't know, okay? So that would be the r equals 2 value. 15. Oh yeah, that's right. And then the next one's 20, right? So do you see, I can generate all the numbers in row 6 of Pascal's triangle without building Pascal's triangle. All I need to do is specify that the row I want to work with is 6, and this R value is going to be the position within the Pascal's triangle coefficient. So if I want the fourth coefficient, or if I want the fifth coefficient, I would put R equals 4. If I want the first coefficient, I put R equals 1. So do you see? I can generate them all, right? Okay. So that's the utility. Sometimes you're going to be doing row 15 and you don't want to build out Pascal's triangle to row 15. So you just use the calculator to say, oh, okay, actually I want row 15. I want the, I don't know, the sixth coefficient of row 15. So I'm just going to put 15 for n, and I'm going to put, what did I say? The fifth coefficient. So the fifth coefficient would be r equals 4, because r starts with 0. Oh my god, look at that number. Okay, we'd never want to build out Pascal's triangle until we're adding numbers with 1,365 in it. Okay, so how do we use the calculator to do binomial coefficients? We just learned how to do that. The example they give is a chooses 5. If you have an older calculator, you need to type the 15 or the 6 before, right? You probably type the 6, and then you go to math, and then you go to probability, and then you choose n chooses r, and then the 6 is automatically plugged in. So if you have an older calculator, you need to do that beforehand. If you have a newer calculator like this one, then you could just put the 6 and the 5 or whatever in here by hand after you get the n chooses r. Okay, so that's how it works. They give an example here for a chooses 5. Now, do you notice that if you were going to do it with the calculator, you just do a chooses 5 and it gives you 56? But if you want to do it by hand, you would plug it into this formula like they did here. So do you see 8 is the n value, so they put it in the numerator. In the bottom, they have n minus r, which is here, 8 minus 5, and they have r, which is 5, so you put it here, okay? So basically, this is creating a terrible expression with 3 factorials in it. If I was to try to figure this out without the calculator, it's not as bad as it looks, okay? So I'm going to show you how that works. 8 factorial, remember, is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I'm not going to put the little dots in between because that's a pain. But you can imagine that they're there, right? On the bottom, I'm going to have 5 factorial, 5 times 4 times 3 times 2 times 1. And I'm also going to have 8 minus 5 factorial. And remember, 8 minus 5 is just 3. So I'm just going to have 3 factorial also. And so then I have 3 factorial. So basically, I have 8 factorial divided by 5 factorial divided by 3 factorial. And, you know, remember, you can cancel numbers out. And let's start with the 5, 4, 3, 2, 1, because, you know, that would be a lot of numbers we cancel out. So we're going to cancel out all these pairs that are on the top and the bottom, because 5 divided by 5 is 1, 4 divided by 4 is 1, 3 divided by 3 is 1, etc. And so I'm left with 8 times 7 times 6 divided by 3 times 2. What's 3 times 2? It's 6. So I can cancel out the 6 with the 3 times 2. I'm left with 7 times 8, which is 56. What do you know? That wasn't too bad, was it? I didn't have to do any multiplication except for 7 times 8 and 2 times 3. Everything else I just canceled out. That's usually the way it works. So it's not that hard to do n chooses r using just by hand instead of using the calculator. Okay, so that was page 3.